Hello smart learners. Let us derive an expression for angle between radius vector and tangent for a polar curve. Taking the x and the y axis, let r is equal to f of theta be the polar curve. For this curve, we need to draw the radius vector and the tangent. So taking O as the origin and OP is the radius vector which makes an angle theta with the x-axis, and PN is the tangent vector which makes an angle psi with the x-axis. Now we need to derive a relation for angle between the radius vector OP and the tangent. We will denote that as angle phi. So here P is the point with polar coordinates r comma theta and Cartesian coordinates x comma y. From basics of differentiation, the tangent is the slope given by tan psi equals dy by dx. I will better write it down. OP equals r is the radius vector making angle theta with x-axis. Pn is the tangent making angle psi with x-axis, and phi is the angle between radius vector and tangent. From the figure and basic geometry, we can see that the exterior angle is equals to the sum of the interior angles, that is psi is equal to theta plus phi. Now applying tan on both sides, we get tan psi is equal to tan theta plus phi. But tan psi is dy by dx, so dy by dx is equal to tan of theta plus phi. And from the trigonometry formula, tan a plus b is equal to tan a plus tan b upon 1 minus tan a into tan b, we can write tan theta plus phi as tan theta plus tan phi whole divided by 1 minus tan theta into tan phi. Since x and y are functions of theta, we can write x and y in its parametric form as x is equal to r cos theta and y is equal to r sin theta. Also, dy by dx in terms of theta is written as dy by dx is equal to dy by d theta whole divided by dx by d theta. I will take this as equation 1. So putting it in equation 1, we need to differentiate y with respect to theta and x with respect to theta. Since y is equal to r sin theta, differentiation of y with respect to theta is product rule. R as it is, differentiation of sin theta is cos theta, plus sin theta as it is, differentiation of r is dr by d theta. I will take it as r dash. So we'll write here r dash is equal to dr by d theta whole divided by dx by d theta. R as it is, differentiation of cos theta is minus sin theta, plus cos theta as it is, differentiation of r is r dash is equal to tan theta plus tan phi whole divided by 1 minus tan theta into tan phi. Now we have to correlate the expression in terms of phi. We see that there is a 1 here, so we need to have a 1 here. That can be easily done by dividing both the numerator and denominator of the LHS, each and every term, by r dash cos theta. If we do that, r cos theta by r dash cos theta gives us r by r dash, plus r dash sin theta by r dash cos theta gives us tan theta whole divided by, I will take this r dash cos theta term first. So r dash cos theta by r dash cos theta is 1 minus r sin theta by r dash cos theta is r by r dash tan theta equals tan theta plus tan phi whole divided by 1 minus tan theta into tan phi. Now both the LHS and RHS can be easily compared. If you see the denominator, there is a 1 here, there is a 1 here, and minus also exists, and there is tan theta here, there is tan theta here. So in where there is tan phi, there is r by r dash. Similarly, in the numerator, there is a tan theta here, and where there is tan phi, there is r by r dash. So comparing both the LHS and RHS, we can write tan phi is equal to r by r dash, that is r by d theta That implies tan of phi equals r into d theta by dr. Equivalently, we can also write cot of phi is equal to 1 by r dr by d theta. These two relations gives us an expression for angle between the radius vector and a tangent. Dear learners, I hope you have clearly understood about derivation. But remember one thing, you can retain more and score more only through practicing it more. So grab a pen and better start practicing now. The next video, we will be studying one more derivation regarding polar curves, that is length of the perpendicular from the pole to the tangent. This derivation will give us a relation between P and R leading to pedal equation. Till then, keep watching. To learn more, subscribe more. Thank you.